Let's see how to derive an expression for the field due to uniformly charged infinite plane sheet using Gauss theorem. For that, first we have to consider a thin plane sheet, a thin plane uniformly charged sheet, uniformly charged sheet. Okay, and the same one here, Gaussian surface. Gaussian surface here is a cylinder. As we have seen in the last video also, we take the same. Okay, with its end faces, with its end face at equal distance, at equal distance are from the sheet. Okay, are from the sheet. We can see that the end faces are P and Q, which are of distance R from the sheet. Okay, at the two ends of the cylinder P and Q, two ends of the cylinder P and Q, the electric field and the area vector are parallel to each other. How? At the two edges of the cylinder P and Q, electric field and area vector are parallel. So electric field is, see, the will place unit positive charge. This is the positive charge. So electric field is outward. The same one. Electric field will be outward. And ds is also just in the same direction. Right. So they are parallel to each other. ds is also in the same direction and normal. They are parallel to each other. So therefore, angle made between them is 0 degree. And electric flux over the edges. Electric flux over the edges is equal, phi is equal to E dot ds. Right? Electric flux over the two edges, so 2 E ds. And we know that cos 0 degree is 1, right? E ds cos theta. So cos 0 is 1. So 2 E ds. This is the first one we are considering. And next on the curved surface. In the previous one we have seen first is the curved surface and next is the edges. But we are seeing here is first is the edges and next is the curved surface. Here the electric field and the area vector are just perpendicular to each other. So therefore no contribution to the total electric flux. No contribution to electric flux. So field and area vector are just perpendicular to each other. So theta angle made by them is 90 degree. Cos 90 degree is equal to 0. Okay. So they do not contribute to electric flux. Therefore, total electric flux is equal to 2E ds. Next one is, as the area of the sheet intercepted by the cylinder is ds. The area of the sheet inscripted by the cylinder is ds. Total charge enclosed by the cylinder. Total charge enclosed by the cylinder. Charge enclosed by the cylinder is sigma is equal to q by ds, and q will be equal to ds into sigma. So this is equation number 1 and this is equation number 2. And next is by Gauss law. Okay, by Gauss law we know that Gauss law we know that phi is equal to q by epsilon, right? Epsilon naught. We know phi is equal to 2E ds and q is equal to sigma ds, right? On substituting this in the equation, 2E ds is equal to sigma ds by epsilon naught. This ds will get cancelled. So E is equal to sigma by 2 epsilon naught. This is the final equation, and in vector form if we have to write, E is equal to sigma by 2 epsilon naught n cap. Here also n cap is a unit vector which is actually normal to the plane and going from it. Okay, and going away from it. Okay, only this much is the derivation. Thank you.